The second project of my project plan for deep learning. This time, sequence processing on time series data. Let's get right into it. I started by making a Power BI dashboard to visualize the data and analyze it. The dataset is about hourly consumption of electricity. There were multiple files. I used the Eastern America file, so it has 145,000 observation. The minimum is 15,000. The maximum is 62,000. It's average. The median. The sum of consumption is 5 billion, which is huge. This is the hourly consumption rate. That's the daily one. It's the same thing, but more smoothed out. The weekly, monthly, yearly. I was just trying to see the seasonality data. I noticed that basically there is some sort of seasonality. I can't tell how many days is the seasonality itself, but there is. As you can see, it gets up, gets high, then low again, normal, then up, then normal, and so on. So I started building some sort of forecasting pipeline. I started by indexing the data with the time series or the dates. As you can see, 145,000 observation data, first taking place in 2002 and the last 2018. This is how the data looks like hourly. Same thing in here in Power BI, but more stretched. As you can see, there is a peak, then normal observations, then peak, normal, peak, normal, peak, and so on. Here I visualized the autocorrelation. As you can see, the first lag is nearly the same as the main data. So usually normally if you say that the next day is the same as today or the next hour is the same as this hour, you'll be very close. And you can see that by time the short memory doesn't get as important as the long memory. So you can see the 24th lag is closer to the first observation than the 12th something. So you need long memory architecture, something like LSTM or TRU, something like that. Here, the train test split, then scaling data, also validation split, scaling the data. In here, loading time series data. Time series datasets from array. I wanted to forecast 24 hours after the start, so it always predicts 24 hours. Started by a naive linear model. The loss was calculated by the Hopper loss or Hooper loss, not sure. Metrics are the mean absolute percentage error and the mean absolute error. Then after training for 3 epochs, got a mean absolute percentage error of 258, which is huge. Then a simple recurrent neural network trained same loss, same optimizer, same metrics, performed slightly better, or not slightly, maybe very much, very better. 33 is really an upgrade from 258. So then I made a deep recurrent neural network, which is the same as a simple recurrent network. As you can see, here's a simple layer of 32 nodes, and here a stacked simple layers of 32 nodes, and here these ones train sequences, so you can train the next layer on those. It performed better, 34, which is, you know what, no, it's not a very big of improvement in the mean absolute percentage error, but there is an improvement in the mean absolute error, I guess, slight one. So it didn't make any difference, actually. The idea is that a deep neural network can catch more trends, I guess. I'm not sure. I love time series forecasting very much. Not as much as I loved computer vision. Then LSTM, or long short-term memory. Same thing as a recurrent neural network, but the difference is that it can have some access on long-term memories instead of just short-term. It performed worse because it wasn't very deep, it was just simple. Then GRU, same thing. It's some sort of architecture built on top the LSTM. It didn't perform as good because, again, simple, not very deep, not very much of stacked layers. Then I tried a convolution in 1D, one-dimensional layer before the GRU. It didn't have much of improvement, actually. It was the same nearly. But anyway, I decided to compare them together, except for the naive one, because the naive one was very on the top. The deep recurrent neural network was the best when it came to mean absolute error, and the simple recurrent neural network was the best when it came to mean absolute percentage error. So I decided to go with the deep RNN because it can always be better to catch more trends, stuff like that. So I trained it on the training dataset plus the validation dataset in here. And then after predicting this dataset and using the mean absolute percentage error, it got a score of 23%, which is quite good. I have to say that this project was fun. It was fun, but it wasn't very fun. I don't love time series data as much as I loved computer vision. The computer vision task was super, exciting and stuff. But anyway, this was my second project. The next one will be an NLP project, which is for me the least interesting of them. I love computer vision, or I'm interested in computer vision. I'm interested in reinforcement learning, interested in some sort of interested in generative AI, but not very much when it comes to natural language processing. I don't like it very much, so I'll still need to do it because I'm doing this to learn and improve. I hope it works out.